Hey everyone, good to see you here. Just turning off the audio in the background. Something of the utmost importance. What's of the utmost importance? I hope it's good news. I hope it's something really awesome. What is of the utmost importance? I'm starting back up Mubot. Is that it? And good to see you here, Andres. Good to see you here. What is of the utmost importance? It is time for questions. We'll turn on the questions at the top. Taking questions right away. Just ask them. We will answer them. We get chapter 7 pulled up. I think that'll be a hot question of the day, because I'm betting people want to work on some chapter 7. Mubot is here, throwing out some points. Let me know your questions right now. I'm getting my Pearson ready right here. My Pearson pulling up. What is of the utmost importance? How long ago was that said? I want to know now. What is it? Find out. A little music right here. If you have questions, let us know. We're just here working away on questions. More chill music than that. Whatever you're wondering, whatever questions. Chapter 7. Yeah, which quiz question? I've got it basically ready to go. Name the question, and we shall work on it. If you say like fiber question, potassium question, we can work on any question you want. Gotta get that R squared timestamp. Any question you're thinking about, just let me know. Residuals, whatever we want to know. Chapter 7 is probably gonna be the hot topic of the day, Maddie. So put the questions in the chat and we'll start working on them. You bet. More points from Mubot. Mubot, thank you so much, Mubot. What? I want to know what this utmost importance is. Oh, we didn't get points out the first time. A little more points right there. I have the quiz pulled up. The Wildfire one. You bet. I'm gonna fall asleep. We'll wake up right here. The Wildfire question. We have it. Let me timestamp it. I knew exactly which one it was. It's like it's the last one on like the order of stuff. The Wildfire question is a pretty good one. So let's see right here. 255, stat 201, chapter 7, Wildfire question. Okay, let's go take a look at this. Here we go. So this is chapter 7, the Wildfire question. Now we're given the intercept and we're given the slope for this. With the intercept and the slope, we have here about an intercept of 3 and a slope of 0.12. Do you think there is a linear relationship? Now we talked about this in our class today. What does that mean the line does to the data? If there's a linear relationship, where's our Patrick star? If there is a linear relationship, the line will do what to the data? Did I delete Patrick? Oh, there he is. If there is a linear relationship, the line will do what to the data? So the green is what we're looking at right here. Don't worry about any other conditions on this. If there is a linear relationship, the line should kind of do what to the data? To a certain extent, pretty decently. Like I'd say that one is also pretty linear. This one is linear here too. If there is a linear relationship, it'll go through kind of the middle of the data, right? So linear relationships go through the middle of the data. So you have to ask yourself, does this go through the middle of the data? And it's going through the middle. Like if you think of Patrick star right here, the middle of Patrick star is being gone through at most points, and it kind of creates a symmetric around it. So we ask ourselves, does this line go through the middle of the data? Is it kind of symmetric? And for the most part, I'd say yes, it is around the line. So yes, the relationship is straight enough, and but not very strong. Good, good, good. It's a little bit weaker because it is a wider kind of relationship. The strength of a relationship is how tight it is around the line. So this is not a strong relationship. It's not very strong since the data is spread out, and that's seen right here, and the R-squared is a little bit lower. Next question is interpret the slope in context of the data. So here's what I want you to do. This is a big thing to do right now. This is years since 1982. It's been 40 years since 1982. Oh my gosh. That's years since 1982. Hey, Andres, good to see you here. Did you have some, if you need to email me. But I think he said he has something of the utmost importance. I'm like, what is that? So we're going to try to interpret the slope right here. And I think we have our slope interpretation over here. And the coefficient of the slope, can I get them both on the screen at the same time? The coefficient of the slope is going to be this right here. For each year increase since 1982, for every year after 1982, we expect the number of lands burned by wildfire to increase by 0.122. Yeah, sure. I guess I probably won't read it on stream then. If you Discord me it, and I might reply later on Discord, so I don't reply on stream. But yeah, if you want to Discord it to me, Discord it to me. Yeah, I'll go take a look at it because the utmost. I'll take a look at it, and you can tell me not to reply on stream, and I won't reply on stream. So Discord it to me, and I'll take a look here in a moment. You're like, have me wondering. So we have right here. We have here the amount of land fires has increased by this amount, and that's because of the positive slope. I don't love that interpretation for the test. I wouldn't use it. I would say for each additional year past 1982, we expect the amount of lands destroyed by wildfires to increase by 0.122. And that's like how many were destroyed that year. So you think about like this year, this is the amount destroyed. So we're saying like this year, this amount was destroyed, but we're seeing an increase to the amount destroyed. Like during this year, this amount of land was destroyed. And each year we see an increase to the amount of land destroyed that year by 0.122. So we're seeing more land destroyed yearly by wildfires. Interpret the intercept. The intercept is meaningful here. The intercept is not a year of 0 because it would be when x is equal to 0. And x is years since 1982. So that would mean we're currently at what year right here, Maddie? What if x is equal to 0, what year are we at? If it's years since 1982, then what would x being 0 mean? What would that mean? If it is x equal to 0, then what would the intercept mean? It is what year? Because it is years since 1982. And if x is 0, which means 0 years since 1982, that means the intercept is interpreting what year, which is a meaningful intercept. So when years since 1982 is equal to 0, which we can abbreviate that. Okay. Yeah. Yeah. Well, okay, cool. I can talk. Okay, cool then. I'll talk about it. Or I'll look at it, talk about it. I'll do it here after this question. So it should be due very soon. Thank you so much, Anders. So we'll take a look at it. And you said it's fine to talk about. So, what year would this be? This would be 1982 because when it's 0 years since 1980, boom, right there, Maddie. Great job. So this is meaningful because if it is 0 years since 1982, that means it is 1982. So we would expect, and then about 3, is it acres or something of wildfires. The intercept is meaningful. The intercept represents the amount starting at 1982, the amount of wildfires burning down. So that is very meaningful. Now the standard error, this one's a little bit odd, but we don't really interpret. Oh, we missed one right here. What does the value of the standard error say about the size of the residuals? And so all you're asking right here is about the residuals, basically. Does the error look small or large here, Maddie? Now, the standard error you could look at and think, okay, that is a value of just how far things are away. But all it's asking you about is the error small or large. Does this model look to have a large error or small error, Maddie? We don't go into standard error on the test, but just look at this. Does this model look to have a small error or large error? What are your thoughts right here? Large error or small error? Like, are the points close to the line or far away from the line? So would this model have a large or small error? That's all we really need to get from this question is there an error that is large or is there an error that is small? I would say large, yep. And why are we saying large? Because the points are very far away from the line. There is a lot of error. Standard error is a measure of error. So you don't need to know SE, which is standard error. It's not on the test. We do talk about it more in later classes, like the standard error being the typical size of the residual. But the standard error here is kind of large. And all we need to do to see that is that the points are pretty far away. I don't love that as a test question, but it should be kind of clear, at least from the points being further away, there is a large error. A model with less error would be closer. Obviously, on the negative zone, how about the error from the line? Yeah, there's some pretty far negative ones. Yeah, these are pretty far below, and these are pretty far above. So the large error would be that there's points generally pretty far from the line. A model with small standard error would have points very close to the line. Like, relatively speaking, I think we just showed one a moment ago. Relatively speaking, where did I put that model? This model right here has pretty small error. And all we're looking at is how close the points are to the line. I can decrease the error of this model, which is just the residuals. I'll disappear so you can see it. If I make the points closer. So if I were to put the points really close here to the line, this is a small error, also standard error. But if I start spreading the points further out, that's a larger standard error. So does that make sense there, Maddie, that this is a larger standard error and this is a smaller standard error? The closer the points are to the line, the less error there is. If the points are more spread out, there's more error, and errors are just residuals. Awesome. Great work there, Maddie. So we would say that there is a lot of scatter to these points, a lot of error. And that's all we're really looking at that question. What does the R squared mean? Now, once again, we want to interpret this. So once again, please write down these interpretations. Blank percent of the variation Y is explained by the variation in X. R squared being 24.3%, we would say 24.3% of the land burned by wildfires is explained by the years since 1982. So 24.3% of the variation in the number of acres damaged by wildfires cannot be, can be explained by the variation in the years since 1982. I think we got it. Wait. You have not completed, the whole assignment. We'll go back here. It's every single question. Hopefully I didn't misclick anything. We didn't. Yes, great work right there. We didn't misclick anything. Maddie, put another question in the chat. We've got open questions, and we'll keep doing some more Chapter 7. Let's head back to the main screen. Okay, let me go look at Discord real quick right here. We got time for more questions. We got a lot of time. Head over to Discord. See right here? All right, let me see. I just have through my membership. Oh, cool. American Student Association. This seems to fit enough of UT as a campus in my professional development. I'm a governor. Cool. Somewhere with this. Okay. It's 2 days. Go to fill out. Yes. Yes. You just need me to fill it out. And so I can do this. I can do it by tonight. You're probably hearing, I probably said that and saw it. Remind me. Put it with an exclamation point. To ensure I do it. By tonight. I like her there. Hippopotamus never forgets. Put in my hippocampus right there. So long-term memory. But yeah, remind me. Message me. Say, hey, Brian, I need you to do that. Or like, can you do this? Say, can you do this? I've had people say like, you need to do this. And I'm like, okay. We'll get that. But no, definitely. Anders, I think you're an amazing student. So happy to have you. Did you come up with the Pint Hype? I'm trying to remember. I'll remind you, it's just that link in the GSSE app doc. Awesome. All right, good deal. Usually I wait till the weekend to catch up on stuff like that, but I can get it done. So I usually on the weekend, I've got usually a list. I've got a board over there where I write down like, do this. And then usually I've got like 4 or 5 letters of rec on the weekend. So usually I'm knocking those out because I used to like wait and then I'd have like 10 or 15 on a weekend. So I usually try to get all of them done, but it's the 11th. So that is this Friday. I did one of the quotes, but helped fuel Pint Hype. Awesome. Yep. The fuel for Pint Hype. What other questions do we have in Anders? Great work right there. Question on Chapter 7 quiz. Standardized test score applications. You bet. That's a good one. Let's go right here to the standardized test score application one. Standardized test scores. That's a good one. That's a tough one. I'll put on a little chill music. This is the big one. Let's go check it out. Here, we're going to put a timestamp. Stat tool 1. And go grab the regression solver. Standardize test scores. So go grab the regression solver while we do this right here. I'm going to go over here to the main screen. And let's go take a look at the regression solver and see where it's at. Here we go. Standardized test scores. Pint Hype, let's go. So the regression solver helps us solve a lot of the really hard problems that we wouldn't do on the test. You can use, you can solve them by hand, but the regression solver found right here under the modules, Regression Solver Pro 3.2. If used correctly, we'll solve it. You're welcome. Aw, thank you so much. Microbiology and physiology. Whew, tough classes right there. Keep up the great work. 100 points for you right there. Oh, you still got all your points? Oh, I didn't reset them from mini-term maybe. Great job. And do remind me, I will get that done later tonight. So with this right here, this question is asking us about, what's our big space? That's weird. So this question is asking us about verbal and math scores of individuals. We're trying to predict what? Are we trying to predict math or verbal? What are we trying to predict right here? Math or verbal? Eventually they will, Anders. Eventually, they always get reset. It was just with winter mini term. I guess someone could be taking 320 who took it. Oh, I think there is. We're trying to predict which one of these. Which one of these are we trying to predict? We want to understand which variable. Do we want to understand someone's verbal score? Do we want to understand someone's math score? We're trying to predict which one of these. So the Y variable is the variable of interest. Predict math from verbal. Maddie, great answers right there. We're trying to predict math from verbal. That's exactly right. And so let's look at this. Verbal and math test scores of a high school graduating class are displayed on the scatter plot with the regression line added. Describe the relationship. Well, it is positive. That's for certain. So both of these are possible answers, B and C, because it is positive. And students with high verbal scores typically have high math scores. It's not that they have high/low. So we would say right here, if someone has higher math scores or higher verbal scores, generally the other one's higher. So that indicates a positive relationship right there. Are there any students who don't fit this pattern? This is actually the what condition. What condition are we checking right here by saying, are there students who don't fit this pattern? We could check all of our conditions right here for practice. We could ask, are they two quantitative variables? We don't want to do that. Are they two quantitative variables? That's the first condition of regression. Yes. Then we have a scatter plot, which is good. Does the line cut through the center of the data? Is there kind of symmetry around it? Yes. For the most part, I would say that the line is cutting through the center of the data. Then we could ask, are there no outliers? And outliers. Great job, Maddie, right there. I'd say we have an outliers. And if we check the plot does not thicken, I would say for the most part, plot thickening is good, as in the plot does not thicken. QQ straight enough. No outliers. Plot doesn't thicken. So there's our four conditions, just making sure we remember them and how to check them. We can also use a residual plot, which would take this line and make it flat. Residual plots would show us if there's plot thickening issues. So it looks like we're pretty good on this. That point right there looks to have a verbal of about 250 and definitely math of 800. So math of 800, there it is right there and right there. So next we have the R. Now we need to know what R is. A very important thing to know is, what is R? R is the value of what? So when you look at R right here, you need to say to me, Brian, R is the value of this. What is R? So R is the value of what? What is R the value of? It tells us the what of the data right now, which we can think of an R that would be rather weak. An R that would be rather weak would look like this. An R that would be rather strong would look like this. And the direction of the line, it doesn't matter, because this would also have a R that would be very high also. So these have R close to 0. And these maybe have R like R equal to, and this is strong, maybe like negative 0.9. And correlation, this is all correlation. This is R maybe of 0.9 and positive or negative. So R is correlation. Very important, we know it's telling us the value of correlation right here. And so since there's a moderate positive correlation, moderate's closer to 0.5, students who score one standard deviation above the mean in verbal are expected to score, and then we need to look for above. So it says below, so that's wrong. And then also, what are they doing to R? They're taking R and squaring it, which is the variability explained, or the variation explained. So if you square R, you get this, and that is the variability in math explained by verbal, because verbal is the X variable, which is going to explain the variability in math. So they've got a decent interpretation of R squared right there that would count on the test. 26.1% of the variation in math scores is explained by the variation in verbal scores. They're saying variability, that's quite fine. And do remember, write down your interpretation. These are questions on the test, and this is almost identical to the way I do it. Blank percent of the variation in Y is explained by the variation in X. Blank percent of the variation in Y is explained by the variation in X. The answer is A. Now we get to the tough question. And this is where you need to take your time and enter the numbers in the right way. So what we have right here is the equation y hat equals b0 plus b1x. So b0 is the value of the what, Maddie? And great work right here. Maddie, I want to throw you some 500 points. Doing a great job on this question with practice right here. I love it when people are following along practicing. And then we need to know instantaneously, if we hear b0, b0 is the what value we're looking for. So we need to know this equation. It also says it down here. B0 is the value of the what. So I need to first find the what for this model. B0 is the value of the what. I'm trying to find first B0 for this model, and that is the value of the what. B0 is the value of the what? The y-intercept, making B1 the slope coefficient right here, because it's for each 1 unit increase in x, and B0 is when x is equal to 0. Great job, Maddie. And so now we go over here to our regression solver found on Chapter 7 modules. Check out the first part of this question if you can't find it. It is found under Chapter 7 modules right here. Regression Solver Pro, modules, Chapter 7. And with this right here, we have our solver. We're going to delete out the information over here. And I'm deleting out what's in the yellow boxes for the inputting of the summary statistics. I'm going to make it so we can see everything on one time on one screen right here, and I might disappear so we can see it all nice and pretty right here. Need to put it right like that. There we go, and put it over here. There we go. Now everything we need is on the screen, and I'll disappear. So we need to fill out the yellow boxes. The first value we have is the value of correlation right here, which is 0.511. That is the value of correlation. The next value we have is the standard deviation of the y variable. Now, the y variable is math, so make sure we go down here, and when we get standard deviation, be very careful. People make a mistake with this right here. It's the standard deviation, I need to make sure I get it right, of math. So math had a standard deviation of this. That is the y variable. Standard deviation of math is this. Now we need the standard deviation of the x variable, which is this over here, 169.9. That is this value right here, the standard deviation of the verbal scores, which verbal is x. Now we need the mean of x, which remember verbal is the x variable. So the mean of the x is 504.9, and that's the mean of the verbal. And then last but not least, we need the mean of the y, which is the math variable, which is 517.1. Now be careful. Any errors will cause you to get this problem wrong. You have to redo it then. It's not fun, but just put the numbers in the right way and then double check that you remember that y is math. So you could put math standard deviation, but you would have to change this because not every problem is going to look like this. Verbal standard deviation, math mean, and verbal mean. Oh, look at that. Oh, this is verbal because that's x. Verbal mean and math mean. So this should be the mean of math. It is the mean of math. This is the mean of a verbal. It is the mean of verbal. This is the verbal standard deviation. It is. Double check those right there. Make sure you have the right values in. And if you don't, make sure to correct them. Now we have here the intercept of 286.582. And we have the slope of 0.457. Double check your numbers. 286.582, 0.457, and then they all need to be to 3 decimal places. So that's the big errors. Ooh, I just misclicked. Be careful. I've done that many times clicking between stuff too. That's a very common error that I'll make. This one says below, and that's the r squared. Good. Don't click a wrong answer by accident. It happens. So now that we have this right here, we would need to interpret the slope. Now, when we interpret the slope, we will have to write it out on the test. So, Matt, if it was class, I'd have everyone be writing it out, but we need to practice this. I'll say it. Try to do it yourself if you want. But remember, we have the slope right here. So we'd say for each 1 point increase in somebody's verbal score, we would expect their math score to increase by 0.457. So for each 1 point increase in someone's verbal score, we would expect their math score to increase by 0.457 points on average. Throwing a little on average right there. So try writing that out. Try saying it aloud because on the test, you won't have multiple choice for these. You will have interpretations. So if you're writing them down, if you're practicing them, that's going to help a lot more than clicking a button right here because they kind of make it a little bit obvious with we expect an increase. So you're down to one of these answers. And it's for each increase in verbal score, we are predicting this many points increase in math. So verbal being the X. For each additional point in verbal, the model predicts an increase of this in the math score. And you would just plug in the value. And this would be good to write down to practice. Down to the last 2 questions, which are very math related. Great questions right here if we give you the equation. Predict the math score of a student with a verbal score of 768. So that is their X value. This one's a little bit easy because all we need to do is take and plug in 768 right here. So we'd plug in 768 and multiply it by 0.457, and then add to it 286.582. Now, if you want, and it says round to the nearest whole number, you can always go to the solver to check your work, because on the solver, it has this little box that I created where you just plug in 768, and guess what? There is the same answer. Now, that one actually rounds down, so I might check it to see if it likes both answers here at the end, but that one rounds down. Now we get to the problem that is really tough, that a lot of people don't get, because you have to solve two things. It says every year somebody makes a perfect 1600. Every year there's a perfect 1600. So, Maddie, what did somebody score on their verbal and what did they score on their math if they make a perfect 1600? So look at the top scores. Tell me, if someone made a perfect 1600, they scored a this. If someone made a perfect 1600, they scored a this. So take a look at the graphic right here. Someone makes a perfect 1600. What did they score? So this will help us solve this question right here. If someone makes a perfect 800 on each, perfect answer, Maddie. And we can see that person right here. That person is, there we go. That person is right here. Now the question says, what is that person's residual? What do you know for certain about that person's residual, Maddie? Like, just looking at it visually, you can be like, looks like the residual is going to be this. Now, we don't know the answer yet, but we're just getting an idea for it. They scored an 800. So we know their math is an 800, and we know their verbal is an 800. So they have a math of 800, and they have a verbal of 800, because they got a perfect 1600. What do you know about their residual, though? The residual has to be this. Now, don't worry about estimating it, but it has to be this, because they're above the line. It's pretty small, too, right? It's pretty small. We could actually estimate it by saying, what is the distance right here? That's the residual. And it also has to be what kind of direction or sign. The residual has to be this because they're above the line. So it has to be this. Positive, exactly, Maddie. Great job right there. It has to be positive. So whatever we enter in right here has to be a positive number, and it should kind of make sense visually with what we're looking at right here. So we know they made an 800. So what are we missing to find out the residual? What are we missing to find out the residual? We need the what to find the residual for them. So we're only missing one more value because we just have to ask how far are they away from this. What do we need to find out the residual? So we're just one thing away from finding that yellow thing now because we just need this to find the residual. It's like, we need to find their what first, and then we can find the residual because it'll just be the distance those are away from each other. We need to find their what value. Exactly, the prediction from the line, right? So their predicted mass score. So what we're going to have to do right here is we're going to actually have to make a prediction for them. So we're going to take that equation that we have. Let's go back and grab that equation. And with that equation, we're going to use it to make a prediction for that individual. So here's our equation. And we're going to need to predict for that individual. Really? And there's the equation. And all I do to make a prediction is do what with this equation? How would I predict this person's math score? We know what their math score is. So what would I do with this equation to predict their math score? So technically, predicted math is just math hat. Technically. So what would I do here to predict this person's math score? And just think about this. We're going right here and basically doing this. That's what we're doing right there. Like visually speaking, we're doing that. So what should we do with this equation right here, visually speaking, to like make the prediction? It's like, so this line right here, we need to solve it by doing what right here to give a prediction, get a predicted math score for them. Exactly. Boom. Maddie right there. You got it. Yep. We're just going to solve the equation right here. Maddie, great answers. We're just going to go right here and plug in 800, and with plugging in 800, we're just going to solve for the predicted math score because that's the y hat right there, which is the equation of the line. We plug in 800. Maddie, thank you so much. Excellent work. This is one of the toughest ones. As long as I don't make a math error, we should be all right. And there's the predicted mass score. That should be about 650. So now that we know this is 650.182. So this is 650.182. That was right? 650.182. 652. 652.182. We do actual minus predicted right there. You're welcome. Yeah, no, this is great. So this makes sense. This should be, if you look at this, that should look to be about 147 units. So if this looks to be about 147 units, because that's 800, that's 200. So that's where 652 would be at on the line. This distance right here, that literal distance should be about 147 away. That's what the residual is. It's how far are those numbers away. So try to like draw this out, try to understand it with the visualizations, and then we can get better and better answers at it. So that's the goal. Hopefully we didn't enter anything incorrectly. Round to 3 decimals. Take a deep breath. Woo! I keep thinking we're going to get something wrong. These are ones where if you make a little math error, and we saw this one could round down. Let's see if it likes it. It does like it. So these have a little bit of a give on them. It has a big give on it. Wow. That one has such a big give on it. So I got a different answer in the solver compared to the calculation on my own. You double check for the expected math score. Oh, yeah, no, the solver it'll be more decimal place. Ooh, let's look at that. So let's go to the solver. Let's see if it accepts this now. So the solver carries more decimals. The solver's like doing more decimal calculations. So let's see what happens if we go 800 minus. Let's see if it likes this. Tell me if it doesn't count it. It should count it, it looks like. I think they have one that carries all the decimals. You just want to make sure, because I think it'll go mad if I do this. Oh man, it's got a big leeway on it. And so did it oh, and then it's worked. Yeah, tell me if it like, if you're within like the tiniest of bits, I'll give it to you. It'd be like, hey Brian, I used the solver. It was off by like 1,000th or 1/10 or something, or 100th. It should work. It should work. And we've confirmed right here that it works. And that's the point of the solver, is it'll solve these things. But if for some reason like a decimal didn't carry right or something, like it carries all decimals where the equation they have doesn't carry all them. So when you use the solver, significant digits in the background, I just have it rounded to that. So you could, take a look at more significant digits. So this is why this is going to do like a more exact calculation. So whatever you're getting down here can be calculated more, decimal place accurate. So good stuff right there. Glad that works. And that's why you might see small differences, is because the solver has the capability to carry way more decimals. There's always decimals that we're rounding. So even though you might see an answer here at the end, this would be like a final solve of this. So you could, do it this way, but even if you don't show the decimals, like even if you don't show them here in the solver, which, that's ridiculous. Now there's a slope of 0. Even if you didn't show the decimals, because this wouldn't make sense mathematically. Does that make sense, Maddie, right here? Like right now we're saying the slope is 0, which is a flat line, but then you wouldn't get a prediction of this right here, because if the slope is 0, then the answer would still be 287 with a slope of 0, because the intercept would be the answer for everything with a flat line. So even if you don't see the extra decimals in the solver, it's still using them to do the calculation at the end. So everything is actually carried over, even if it's rounded in the solver, which is kind of nice. So that's why you might see small differences. Like, it's a long answer to say, yeah, Maddie, great work right there. Let's do more questions, Maddie. I bet people are excited, because that's a tough one. No, it's confusing, because it's like, you think about it, and you're like, wait a minute, why is Ma Pearson given a slightly different answer? It's a really good question. Always question these things. Be like, why does this not work? What's going on right here? What's happening with the world? Make sure. Can you message me here one more time, even if it just says hi? That will make your messages appear as unanswered, and I will be able to remember better to do this later. Thanks. Anders will see that. Cool. Let me go away from his message so I can see it. Awesome. Got people in the good stuff right there. Chapter 7 quiz, classified ad in the paper and used cars. Let's go check it out. No, Maddie, this is great. Maddie, great. Thank you so much, Maddie. It's right before spring break, and I appreciate it so much because sometimes I've done stuff right, like tomorrow maybe. Tomorrow might be like nobody might show up. Use the advertised price for, is it, so chapter 7, classified ad in the paper and used cars. Classified ads one. Here we go. Found it. Classified ads. This is all people want because this is not the easiest assignment. Chapter 7 classified ads. Let's go check it out. Classified ads. Here we go. Okay, so we have classified ads in a local paper with used cars. So the first thing, and this is actually a tough question to start with these graphs. What you want to notice is you can actually do this without graphing it in jump. Do we need jump? We will need jump to do the correlation. Okay, so let's go ahead and do it in jump here to get the correlation. We are trying to predict the price of a car from the age of a car. So I think we only need correlation. So we might not actually fit the line to it. Let's go ahead and grab the correlation. Here's how we're going to do it. We're going to go right here to the data table and click it. It has column names. Please notice it has column names. What do I mean by that? I mean at the very top, there's a name of a column. This is going to be very important when we bring the data in that we paste with column names. So we're going to copy the data to start, copy to clipboard. We're going to hit Control-C or Command-C on a Mac. It is now copied and we have it in our computer's brain. So with this, we're going to go back over here into Jump. You can be anywhere inside of Jump and go to File, New, Data Table. Pause right here. So anywhere inside of Jump, you can hit Control-N or Command-N and hit File, New, Data Table. With File, New, Data Table, it should work on all of them. Double check, Casey. We could take a look at that too. Double check, make sure it should work on all of them. I'm using PC right now, so it works on all of them. Just make sure each number is correct, because one number in the wrong spot or a wrong decimal, and no, believe me, I've done it. I've put a wrong number in it. It implodes. It says no. We're gonna go right here to Edit Paste with Column Names. And with pasting with the column names, make sure they're both blue. If they're not blue, start over and make sure to paste with column names. If they're red, that means, oh no, you're welcome, Casey. This means you've pasted them as categorical. Don't try to undo it. Can you undo it? I think maybe you can nowadays. Yeah, you can. You can undo and redo it. Make sure they're blue. Pasted with column names, and that way you get the column names at the top, and it doesn't see them as categorical, and this is going to be very important. So now we want to explain the price with the age. So we're going to go over here to Analyze, and we're going to go to Multivariate Methods, Multivariate. We're actually going to do this with the correlation platform to take a look at it, because that's going to get us the correlation to start. And one thing we want to know is older cars sell for less. So let's go ahead here and do the multivariate. We're just going to double click both of them. So click, 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 click on both, and then go ahead and click OK right here. Now we have the relationship. Notice how this is the one we want. And it's a little bit tough because you have to notice that there's 3 points right here. There's 3 points. That's going to be a big thing, I think, for this one. So there's 3 points right here, cars with 9 years of age. There's the negative correlation, all that good stuff. So we have what the graph should look like a little dip downward with 3 points right here. Let's see if we see that. A little dip downward with 3 points. So it's got to be one of these two. So let's look at this. This has... There are 3 points right there. 1, 2, 3. These are more equally spaced. There's 2 cars over there. Okay, you see how there's 2 cars right here. And over here, I think that's actually the 2 cars. Those 2 cars have a virtually identical selling price. I think it's going to be the last graphic. And I think that's 2 points. That is 2 points. It might be hard to see this, but that is 2 points right there. That says 2 points. It's because those 2 cars, I thought I was going to open up the jump data sheet right there to show you, those 2 cars are virtually identical in price. So this is a tricky question. It looks very easy from the start, but the 2 cars that have virtually identical prices are basically overlapping, and those points look like that. So in our graphic, we'll show our graphic again right here. You see a similar plot right here. And I'll show you our graphic right here. There are two cars right there. They're just so close in price. So here's our graphic. There's their graphic. You can see the 3 points right there, 3 points right there. And these 2 points are almost perfectly aligned right here with this point right here. And you can see it. It doesn't look like the other graphic. This graphic right here has more separation between these 2 points and those points right there. So just look at the small differences. Very tough, but you don't see the 3 points right here being basically above. That is a tough question. At least visually, it's hard to tell, but those 2 points are right there, and you can just see the extra little, it's a little thicker right there. So that's 2 points. Very tough. Tough question to start, but it gets easier from here. Describe the association. Well, it's obviously negative. It's mostly linear. Ooh. It's pretty strong. That's mostly linear. Does a line go through the data pretty well? I'd say yes. And if they say no, I'm going to get mad. Do you think a linear model is appropriate? Yes, because it's relatively straight and there's no outliers. Really, the only thing we're looking at here is relatively straight. They shouldn't mention no outliers, in my opinion. They should ask, is it relatively straight? Does the line cut through the center of the data? And we could also look at this by going here and doing analyze fit y by x. And we could look at the price explained by the age. And it's mostly linear. There is a little bit of a bend to that. There's just a tiny bit of an issue here. Like, this is where I see a tiny bit of an issue, but that's not a huge issue. Even the lack of fit says it's not. It's iffy, but we don't know lack of fit right now. So it's really not that bad. Anyways, we could look at a lot of different things with that. It's not that bad. I'm going to get mad if it says there's a bend to it. No, because data points do not form. Yeah. So this would be the only possible answer. But no. Compute the R squared right here is this. Oh, so it tells you R squared. So you actually don't need to use jump. But using jump, we can confirm that the correlation is negative 0.945. What we're going to do right here is we're actually going to use their number. And we're going to do the steps of square rooting R squared. Now, once we square root R squared, what must we do to it? This is a common mistake. When you square root R squared, so Maddie, what must you do when you square root R squared? So I just square rooted my R squared. Then you need to do what? Which this is on the Canvas content. Once you square root R squared, you need to then do what? So what do you need to do after you square root your R squared? You need to check the what of the correlation. So you square root R squared to get R from R squared. And you take the R squared, square root it, and then you do what right here, which we can see by looking at it. It's actually, make it negative because of the sign of the graph. Boom, right there. So that's got it. It is negative because it goes downward. So that is excellent. Maddie, amazing work today. Great practice on this. Explain the R squared, where the R squared is the percent of variation in Y, explained by the variation in X. So we can say right here, it's one of these two. A linear model on advertised price accounts for this. So we're accounting for the variation in price. Age explains this much percent of the variation in price. So it's accounting for the variation in price. I don't love the way this one's written. I would say 89.3% of the variation in price is explained by the variation in age. So once again, practice your interpretations. That would count on the test. If you feel like the graders are mean to you, let me know. They're just trying to do their job. So why doesn't this model explain 100% of the variability? What craziness are we going to read here? It is not impossible for something to be over 90% variation. The age are rounded to years, but should be in actual months. That wouldn't do it either. The data cannot contain more than 10 points. No, you can have models that are perfect. Other factors are explaining it. So there's other things at play right here, other X variables that are explaining it, and we should be all right. Please tell me it's linear. We got 100. This one is mostly linear. Whenever you're checking out linearity, you want to see it's mostly linear. If you're wondering something that would not be linear, this is not linear. More specifically, we would see it in a scatter plot to start. This is a non-linear relationship that also has plot thickening. So if you're wondering, when do we fail the conditions? This is definitely an issue with linearity. And what do I mean? The line does not go through the middle of the data. So this one is not linear. It looks like a Nike swoosh, as people were saying in class. It also has plot thickening because it starts out very thin and it gets thicker. It could get thinner, but plot thickening is whenever we see a change in the strength of the relationship. So this is not linear and has plot thickening and might have some mild outliers, but probably some of the outliers are due to the plot thickening. Either which way, this is not a good linear model, where the one we just saw in this question is a pretty decent linear model. So this right here, this data right here is pretty linear, good sort of linear regression right here that we could do. And that's the whole point of checking the conditions. Like, should we be doing this? And yeah, for this data, this seems like a good idea. Seems like a good idea to do linear regression on data that looks mostly linear with few outliers, with relatively consistent thickness throughout. That's a pretty good relationship right here. Heading back to the main screen. Maddie, we've done some really great tough questions. Which ones do you have, Maddie? We got time for more questions. Let me know. Drop those questions in the chat. Let me know. Whew. I tell you, Monday at spring break, I'm just gonna be like, let's sleep all day. I can't believe it. You know, after tomorrow, we're gonna have, and we have an event tomorrow night. Oh, I gotta announce that. A whole bunch. After tomorrow night, it's just gonna be 10 days or so. Calories in a burger with the fat, you bet. I love some of these questions though. I've solved them tons and tons of times. What I like is I almost like find new ways of doing them. Or I try to like find better ways to explain them. My goal is like we can understand them on a better level. So I'm almost trying to do that right here. I know, right? I know. Probably I'm playing a ton of video games. I probably got to start a new one. I've almost beat Bloodborne. Bloodborne, really great game. I feel like Dark Souls games. But I've almost beat Bloodborne. I feel like she told me the person who you level up with told me I need to go meet someone somewhere. And so I was like, uh-oh, that sounds like endgame stuff. I don't know when the game ends, but she was like, go meet so-and-so at the such and such place. And I was like, ooh, that sounds like just telling me to go beat the game. I was like, oh no. And everything's on fire. I'm scared. It's bad. End of game bosses. Stat 201. And we're also playing Horizon Forbidden West. Great game right there. Fat and calories. I've got the new Spider-Man Morales game. That'd be good. Here we go. So with this question right here, we are trying to predict the amount of fat in a burger using the calories. Now, I like this one. We might use the solver for it. Pretty good to use the solver. You could also use jump. Either one's fine to use. I'll show you how to use the solver with this one for the time being. So once again, have the regression solver open. The regression solver can be found here. You can input data into it, and you can also put in the summary statistics. And it mainly exists to do the summary statistics, but it also exists to put data inside of it. So let's go ahead and take the data right here. And remember, we are predicting fat from calories. And we're going to go right here to copy to clipboard. And we're going to copy it with Control or Command C. We're going to go over to the regression solver over here, zoom out a little bit. We're going to go back in time to pretend we didn't put stuff in here. Can we go all the way back in time? We can. So now that we are all the way back in time, as though we have a regression solver we just downloaded, we're going to go right here, and we are going to input into the regression solver this information. Oh, lost my copy paste. We're going to input into the regression solver, copy to clipboard, copy, copy, copy. And then we're going to input into the regression solver the following information. Now, it's important to know that fat is going to be the what variable. Fat is going to be the what variable. Just one letter in the chat for 100 points right here. Fat is going to be the what variable. Very important to know this, that fat is going to be the what variable. If we make a mistake here, everything goes haywire. So fat is going to be the what variable. Fat is going to be the what variable. What variable will fat be? Fat is the one we're interested in, the response variable. It's good, Maddie, good answer. I think it starts out with the question with that. So it does start out the question saying, explain why you cannot use this model to estimate fat. So it actually starts out with the reverse. So it does start reverse. But then with this model down here, fat will be the y variable because it's the predicted one. So that's the predicted, the fat with the hat on it is the predicted fat being the y variable of interest. So Maddie, another 100 points. We're here to practice, and great practice right there. The model is going to predict fat, which means fat is the y variable of interest, making calories the explanatory variables that explain how much fat is in a burger. So make sure right here to put fat, the vector of fat, the values into the y information, and calories into the x right there. So very important we have it set up that way. Yeah, no, that's the practice. No, good practice right there. The y variable is the variable of interest. The response variable, the x variable is the explanatory. And if those are reversed, that causes a lot of problems. This gives us the intercept right here and the slope. So now that we have intercept and slope, we could input those values in oh my gosh, I can't even speak, for intercept and slope. Intercept is negative 16.823. Let me double check that. Negative 16.823. And slope is 0.087. I think that's right. So double check your numbers. Have them on the screen at the same time if you can do that. Negative 16 point... Oh my gosh. Oh my gosh. Look at that. Look at that. Negative 16.823. And we could even round this to help ourselves out. I'm going to round it. So let me go to round. There we go. And we'll round this to 3 decimals. And there it is. That's going to help us to make sure we have the exact numbers. Negative 16.823 and 0.087. 0.087. Boom. So make sure you have these entered in exactly how you see them. You could also use the increase decrease decimal button like I did to get them to the exact amount of digits you want. That's the increase decimal button or decrease decimal button. Highly suggest using it to make sure you round exactly the way it wants, and you can always extend or decrease the decimals. Let's look at that first question though. Explain why you cannot use this model to estimate. So someone made a model right here. A model was created that estimates the number of calories. So that makes calories the y variable because they're trying to estimate calories when the fat content is known. So they're using fat to explain calories. So explain why you cannot use this model. Estimate the fat content of a burger with 600 calories. So they're trying to predict fat right here. The regression model was predicting calories from fat, not the other way around. The original one was predicting calories, so we cannot estimate fat. It's a bit of an odd question. It's saying we made a model predicting calories from fat. Why can we not predict fat? Well, because we're predicting calories from fat, not the other way around. Not a big fan of that question. This one right here, knowing the regression model is pretty important. And once we get the regression model, we should probably interpret the slope and the intercept. The slope of this model would be, for each additional calorie a burger has, we would expect the fat content of the burger to increase by 0.087 on average. Practice that. For each additional calorie that the burger has, we would expect the fat content to increase by 0.07 on average, 0.087 on average. Hey, Adam, good to see you here. If you have a question on 14.5 or anything, let me know. We can do that next, whatever you want. I think the story I got confused. You try to answer the... Oh, yeah, the first question is a bit weird, and I think that's what maybe happened when you answered it. Maddie, thank you so much. 100 points. That's weird how they do that. They're like, hey, we made the wrong model, so let's make the right model now. So it reverses it to start, and then fat is the y variable of interest. The intercept is not meaningful because you can't have negative fat content. But you can have a 0-calorie burger. So I would say when the calories of a burger is equal to 0, we expect the fat content to be negative 16.823 on average. But that is not meaningful or logical because you can't have negative fat content. Last but not least, and Adam, good question right there. With a radio button dyslexia, struggling. Oh, we can take a look. If you can send it to me, maybe take a look. I saw a lot of messages. I got a lot of messages to reply to. All we're doing right here is plugging in 800 and 52.5. And so we can plug in 800 here too to check our work. So, wait, 600. Hopefully I didn't plug in 800. And then, what? Oh, it's going to be minus. I think I did plug in 800, it looks like. And then minus 16.23. So that's the answer there, 35.4. I think I still had that last question in my head. Yeah, I did. Ooh, it better have some leeway on this question. I had a question about 5 on the homework. Of course, of course. Yeah, well, we did that earlier, T, but we can do it again right here. So we can do the residual one again. We'll take a look right here. We'll hop down to it. Let's go take a look at that. We'll go back and do that, T. Good question, T. Thank you so much. We'll do that here next. And then, Adam, if you can send me your stuff, we can probably take a look. I'll try to do it like kind of so people can't see and we don't spread around answers. But no, T, I want to throw you some 500 points, T. Thank you for being here. Thank you for asking. No, we've got pretty open questions right now, so that's when we go back and do more stuff. That's the hardest question, so thank you for asking. That's the hardest one on that one. I'm a little bit worried about this one, though, because we get 35.4 and the solver gets 35.2. Let's check our answers. We get it right. If we had used the solver, would we get it right? That's the big question, and we would. If we didn't use either and we kind of guesstimated, you see, they know. They're good. They carry the decimals, so using the solver or doing it with the equation both give the right answer. So pretty interesting that 35.3 is wrong, because the solver does it all. 2 quick questions. Yeah, we're doing the activity today. Yep, later today. And are you going to have office hours during spring break? No office hours during spring break. But we will do a review at the end of spring break. We are doing the activity. Mine varied from, so you should get 35.1 or 34.9 if either one of those are counted. So both of those should be counted correct, because both of my answers were counted correct. What's up, Troy, right here, office hours crew. So let me know if you put in the answer and it says it's wrong. If it says off by like a decimal, I'll make sure you get it right, because it shouldn't do that. Let's go look at that residual question. And so we'll head back over here. Let's go do the SAT question. And Adam, tell me if you messaged me that. So good to see you here. Kayla and everybody. We're going to do the SAT residual question, which is the toughest question of the SAT. T, I just want to give a big shout out right there. You've worked through a very tough question. You're on the last part of it. So this is SAT residual question. So can we do it? Yeah. Tell me which one. Kayla. Let's hop in here. We'll do some assignment 5. Got a question from Adam, and then I think we have T's question. So let's go ahead and take a look at the residual question and see how to solve it. And one moment, I'm getting the question ready. Okay. Hop down here. Here we go. Sending right now. Awesome, Adam. So with this right here, this is solving the last question, which is the residual question. To solve the residual question, we need to have this equation. So check out the earlier part of the video. T, are you doing all right? Do you have your equation found via the regression solver? I've been using the regression solver for other stuff, but if you have your equation, you're good. How are you doing on that, T? You have the equation. We will need that to solve this problem. So we will need this equation to solve it. Yes, you're good. So then let's talk about how to solve this now. It wants us to find the residual of somebody who made a perfect 1600. If somebody made a perfect 1600, what did they score on their math and what did they score on their verbal? If somebody made a perfect 1600, what did they score on their math and what did they score on their verbal? If someone made a perfect 1600, what did they make on their math and what did they make on their verbal? So they made 1600 overall. What was their math score and what was their verbal score? 800, 800. T, great answers right there. They made 800, 800. So that would be actually this person right here. Well, wait a minute. If we know this person right here made a perfect 1600, then we can actually see their residual. Now, this is the residual known as E. We know that this person's math score, let's do math in green right here. We know that their math score is 800. So math is 800. So tell me this. What other value, this is good for Kayla too, for doing this with our class, what other value do we need to find the residual? What other value would we need to find the residual, which is this yellow distance right here? We would also need their what value to find their residual. So we also need their what value to find their residual. So we know they made an 800 math. Close, T, good guess right there. To an extent, I think so. Which one, Sutton? We did one earlier. Tell me which one. And we've got time for a few more questions. So Sutton, can you give me the start of the question, Sutton? We did one like that earlier. And we'll try to do the other one too. And I think Kayla's a question, but yeah, put the question in the chat and we probably can, Sutton. I think we have just enough time. So we need the what else? Residual. A residual is equal to this right here. And we have this value, and the residual is what I've highlighted in yellow right there. So we need the what value What other value do we need right now? So we've got a little color coding to help out with what we see here visually. This is the actual value, like what did someone actually make? What is their actual Y value? Residual equals actual minus what value? And then the residual is E, which is the distance between those two values. So you can see here the distance. So that distance right here is the residual. That is E. And so what does this value mean here? What is Y hat? And if we go look at the question, it might give us some clues that Y hat is the what value? Predicted, 100 points right there. It's the predicted. That is the predicted right there. Residual wrap. Residual equals actual minus predicted. Great memory right there. Kayla, another. More points on there. So residual equals actual minus predicted. So we need to find the prediction. So let's take this equation right here of the line, which is right here, and use it to solve for a prediction. How am I going to use this to solve for a prediction? I've got the equation of the line, and I just need to find the predicted value for this individual. How can I, like, what do I need to put in for this person to get a prediction for them? So somehow I need to solve this equation, and I need to somehow make a prediction for them. I need to know their value of x. Well, that's going to be somewhere along this x-axis, right? So I need to know their value of x to make a prediction for them over here. So that would be their predicted value. So I need to know their value of x. You bet, Sutton. Thank you so much, Sutton. So I need to know their value of x. What is their value? They made a perfect 1600. So what is their value of x? That'll allow me to get their prediction. And then I can find that residual by finding that distance. What is their value of x right here? So their value of x would be what? It would be 800. T, great answers right there. It is 800. They made an 800. So now we can solve for their predicted value. And what we want to notice about this is the residual is most definitely positive or negative. Which one should it be? I'm just solving the equation down here on the bottom of the screen. The residual of this individual, is it positive or negative? So is that person basically above or below the line? Is it positive or negative? And then we can see right here. It's going to be 6521. So the actual is 800 minus 6521. It is above, so they are positive. Great job right there. T 182. So we should get a positive number. And let's go ahead and solve this. 800 minus 652.182. And there's the residual right there. And does that look to be a distance of about 150-ish? Like maybe, see, that's 200 down there. That's 800. So this is about 652. So does this make sense right here, T? We should get a number that kind of makes sense. Like when we look at it visually, it's like, yeah, it's about 150 units on this axis. Like this is a total of 600 units. And yeah, that looks to be 147.818 units. That's how far away that point is from that. It's 147.818 above its prediction. They were predicted to be this. That's where the line predicts them to be. Oh, great job right there, T. Another 100 points. You got it. Yeah, so you might have found the predicted. Yeah, you just did the predicted. Yep. And then remember, the residual is the actual minus the predicted. So it's a two-step problem. T, great job right there, T. I want to 3,500 points, T. Do not worry if I've already solved a problem. It is your office hours. You're here, and I appreciate that because this is one of the toughest problems. Don't worry, I've worked this one a lot of times. This is my 1000th time solving it, maybe. So I'm here to solve the problems and help out. And then we work through it and we try to understand the steps and understand the context of it. Thank you, T. Great work right there. Okay, I think we have Adam. I might have to look at this later because it's hard to do that on stream. But Adam, I'm going to take a look at the 475 stuff here in a little bit. You're trying to add the radio buttons you were saying. It looks to change between stuff. I think Kayla had questions. Did you just want to start the question, Kayla? Start the assignment? Sutton we'll do Sutton's after Kayla's. So Adam, I might have to look at it because it's a little bit hard to I don't want to show the app. So that's the problem with doing 475 on stream is I can't show it. They're like, oh, look at this. And then other groups could technically take it. So we'll do some 320. 320. BS 320. Assignment 5. Starting the assignment. We'll probably start it up right here. So let's see right here. Assignment 6. Assignment 6. I'm good with starting at 2. I tried finding the hardest looking one. The hardest looking one. It's a good place to start. Always find the hardest one, And that is a good place to start the assignments. I like that right there. Oh yeah, let's go over here and take a look. We'll go grab the 320 assignment. And assignments coming right up right here. I love working in R. I oftentimes come up with new ideas. My brain blinks. Okay. Let's take a look. Here we go. And let's start up the assignment. He has, did you run it off screen? I haven't run it yet. Just got here. I just wanted to be here at one of, oh, yeah, of course, Barrett. Good to hear you. Have you here. Yep. Lots more. Did you run it off screen? I haven't ran it yet. I might, because I'm probably have to debug it. You have it. Let me go. I'll look at it next year, Adam. Let me look at it next. You got it, Adam. We'll take a look and we'll figure out what's going on with that. Let's go look at some BAS 320. So we got, I'm going to take the timestamp again real quick on that because took a moment. There we go. So here we are with the start of the assignment right here. And we've got, it's from the homework packet. Great stuff. You need to load in the EX3 abalone data right here. And we've got all of that going for you right here. Everything going on good. And I think that's it. Let's take a look. This is number A from the homework packet. So let me get the homework packet pulled up right here. Homework packet. Oh, I got to go to the screen, the slide for it. Let me go over there and get it real quick right here. So the homework packet. So BAS 320. And we'll take a look right here. The homework packet, going to pull it up here in just a second. And let's go to the modules. I'll show you the screen here in a second. The modules on the screen. There's actually no errors at the moment. I just need to figure out what I need to put in the server. I got the radio button to work. I've gotten an error. Yes. Awesome. What do you want your radio buttons to do? Message me on the Discord with the radio buttons. I should be able to fix it up. We're going to grab the homework packet here. Homework packet. Where is it? Why am I? Oh, there we go. Textbook homework packet. Cool. And homework packet here. Cool. And let's go down to it. You need to load in the EX3 abalone, done that. And then right here, chapter 3, exercise 3, 126. And here it is right here. Okay, cool. And it's on, there it is. EX3 abalone. Boom. Okay. Make a relevant scatter plot using the additional argument. And we could do that right there. So it says first that we need to predict meet weight from diameter. So how are we going to do this to start right here, Kayla? How would we predict meet weight from diameter? How would we predict meet weight from diameter? How are we going to do that? Meet weight from diameter. So the variable is meet weight. You can call it MW, or it's capital MEAT dot capital WEIGHT. And then from diameter, we're predicting meet weight, which makes meet weight the Y variable. It's the predicted variable. And so how would we make this model right here from the data set EX3 abalone? So what would be the code for this right here? So how would we do this? How would we start this code to predict meet weight from diameter? So we have here, what will we do? I'll give it a moment. And so how would we predict meet weight from diameter? How would we make a linear model to do that? And what would we store it into? So we want to store into something a linear model predicting meet weight from diameter with the data, and then put it all inside of an LM, right? So an LM. And so the great news is, and it's meet dot weight, exactly, I said we could abbreviate for the moment. And diameter, I think, is a capital. We'll find out the hard way if I misspelled these things. Data equals EX3 abalone. And that did it correctly. Now I'm gonna show you a trick right here. All that put together. Nice job right there, Kayla. And think about this. If someone from 201's listening, they're probably like, what is he saying? He's saying, we need to predict this, from the data set this. We need to make a linear model. And when you hear it, you're like, oh, he's saying store into the object M the linear model of, the Y variable meet weight of the X variable, explaining it diameter with the data frame EX3 abalone. Kayla, when you look at this, On a scale of 1 to 10, 1 being this makes no sense of what this is doing, 10 being this makes perfect sense, how much do you understand what this code is doing? Can we do the mortality problem? Yeah, I think we can. We got 2 more. We might have time for those 2 more 201s. Barrett, you got it. I think we can. And we'll go 5 more 6 more minutes on this 320. And so Barrett, thank you so much. Let me write down what I'm going to do next right here. We got BS 475, shiny question. Then we have 10. Okay, that's awesome. It's like once you've seen it a whole bunch, you're like, oh, we're just making a model predicting the Y from the X from a data frame of data from an Excel spreadsheet. Mortality and calcium, and there was the car prices right there. Cool. Oh, we've done a lot today. This is our list from today so far, and we've got a lot done. So great work. Great office hours, everyone. So I'm not a big fan of using this methodology of making a scatter plot. So I'll show how to do it. You can go over here and do the plot of the variables, and then you can add to it the AB line of your model with the color equals to purple, of course. So I'm going to do not purple right here. Oh, did we not spell purple correctly? Is it coal? There, it's coal. And also in the plot, it mentions you can do like line width equals, no, we're not doing line width. We're doing CXC for point size. And they want like a point size of that. And I'll put it on the next line. And then we also have like a point style PCH of like whatever. So it does mention what you can change. I think it's totally cool too. And you can change all these things right here. The point style, the point size. So you can actually control CX is character expansion. That's what it stands for. Like this is like a character right here. It's an X. So we're expanding it, or I can make it smaller. So I'm making it smaller right there. You could also change the color of them. The color equals orange. Should work. There we go. Beautiful plot. Beautiful plot. And main equals Y. There we go. So you can do a lot of different things right here. A lot of different arguments if you know them. Okay, what does the CEX means? Character expansion. So it's these X's right here are the character, and it's how much I'm expanding them. So I can make them really big, or I can make them really small. The PCH is what type of point style it is. This is the point, like the character type. And so there's different ones, like it'd be easier if I make it bigger to see. But that's like what kind of thing you're using. I think like 13 is one I like, right? That's, yeah. So this changes the way they look, and this changes the size of them. Does that make sense? So this is your size. Like for all intents and purposes, this is just the size of it, and this is the character you're picking. Now, don't put size in character, but PCH is the character you're picking. Yeah, I think so. The annual mortality. Did we do annual mortality yet? I don't know if we did. There we go. We can try. We'll do a few more. We're going to do about 2 more minutes on this. And so that's what that does there. Next but not least, we have the following. It looks like we're going to do a check regression, I hope. Ooh, check in regression. Let's try to get to that. Let's go down here to the check regression, Kayla, because we talked about that. And well, there's choosing transformations, which we haven't talked about yet. Check whether the transform model. Wait, here we go. Find transformations. Do we not? When do we check the regression? Oh, well, darn it. Oh, yeah. So let's talk about the find transformations right here. Well, so we can fit the model, which we just did. Here's the fit of the model. And the fit of the model, we can visualize the fit. And there's the visualization of the fit. And the reason we're going to transform this data, which is really cool to talk about for 201 if they're listening to linear regression, is there's a very not what relationship to this data right now, Kayla. If you look at this, and this is why we would transform it, the relationship right here fails what condition? It's probably one of the biggest conditions with this data that it fails is what right now? You look at this and you say, that has problems for regression because we call it this regression. Non-linear, Kayla, exactly. There's a huge non-linear problem. So when you transform data, you're doing like mathematics to like square root it, to do all these different things. And you could do all different kinds of things, but watch this. Find transformations. And what do you think? Take a wild guess at what find transformations is going to do? When I run find transformations on my model, just what do you think it's going to do? It's going to try to what for me? Find transformations, crazy code is going to try to do what for me? Just think, why did we call it find transformations? It's going to try to do what for me? The goal of find transformations is to do this. Crazy goal right here, if you think about what the code is named. The goal of fine transformations is to... It's going to find the transformations. There we go. Yeah. That's what it does. And if you look at this, here's with no transformation. And we were talking about R squared for 201 today. What do you notice about the points right here when we do the best transformation? We're actually trying to increase the what? If you look at this right here, we are trying with these transformations, that's why I increased it, we are trying to increase the R squared. So the goal with these transformations is to make a more linear model that the line would explain more of the data. And I think we've done that. So if you look at this, the R squared is much higher, and here's what we need to raise the Y to, and here's what we need to raise the X to. We might come back and do this, but we're trying to make a better model that explains more of the variation, because R squared is the percent of variation in Y explained by the variation in X, and the transformed model, with the percent of variation in Y explained by X is now 95.7%, almost 96%. So we explain way more variation in Y using X with our transformed model. The transform model goes from about a 77% R squared to a 96% R squared. So that's a lot more variation explained. So the transformation was a huge help right here. It really brought us a much more linear relationship. That's the best one. That's the second best and the third best, respectively. But this is way, way better. So the transformation helped a ton right here. So that's why we would use transformations. And we'll be talking about this tomorrow. So great work, Kayla. Any other questions? I'm going to head back over to the main screen, but does this feel better getting started here? Are we doing chapter 7 today? Correct. We're kind of doing a little talk on chapter 8, but it's mainly chapter 7, but they are very blended together with residuals and everything. Zach, great questions right there. We'll be finishing all of chapter 7 today. Exactly. The transformation does way better. The increase in R squared is something we really like. Also, it fixed a linearity problem. At least it looks like this. And then we'll talk about fitting the transform model, which the notes have. But message me if you can't do it. Awesome, Kayla. I will see you tomorrow. Great work. Excellent work. We got time. We got 2 more stats, 1 question. So let me turn off the taking questions. Let me see, Adam, if I can get this done over here. I might have to look later. Let me go look at Adam's message. There it is. Okay, here's the thing. So you're trying to add a radio button, Adam? We're going to try to do. I'm going to send out the message 201, class in 30 minutes. I had someone tell me that people thought class was canceled because I didn't send the message out till like 15 minutes before class. And I was like, oh no. I was like, sometimes there's always class, unless I say class canceled. So unless class is canceled, there's always class. We're going to try to do 2 more questions. Got 1 person watching, probably me. Go class in. There we go. We've got the link. And we'll double check it. Good to go. Okay. So Adam, let's see here. Hamburgers. Oh man. Oh, we should have got those. What are you stuck on, Adam? I've got the app pulled up. You're trying to add. Well, you got a UI below your server. You got the radio buttons. Okay, so you're trying to... Okay, you want different charts. Okay, I see what you're doing. Ooh, the radio buttons are clicking but not declicking. The radio buttons are not declicking. So you'll see if I get it to display a normal stock line, but I want it to be able to click these radio buttons and the graph will change. So, well, right now the buttons are... So, it also doesn't have a name. So the radio buttons... doesn't have a name right now in the server. We need to give it like a name in the server. And you've got the choices, all that labeled. It needs a name, but this is going to require R buttons. Pick a graph. Okay. Let me run this right here. It would require... Okay, good. I think this fixed a problem. Okay. So right now, and I'll show you what I did. I'll show you what it looks like now. So when you run yours, does it allow you, like now I'm clicking buttons and the buttons are actually clicking and declicking. When I first ran yours, it didn't let me declick the buttons. And you need to make sure you have a name for this in the server, and also you also have a title for it probably too. I mean, maybe you could put no title. I think the problem was no name in the server. What you want to do is you don't want to try to make all of them. So never start out by trying to connect every graph. So what I would do, and you might, I wouldn't put radial buttons to change them. I would use different pages. So I would use different pages to have graphs on different tabs. Right now, probably the biggest issue I see with the app is the presentation of it is a little is not going to get the highest points on the presentation. I probably would try to put things on tabs. So, maybe you have a tab of a candlestick chart. I think that's going to be better than using radial buttons. Like, it's going to be a lot more work to put a radial button, but you could say like charts or something and have different charts, and you could have sub tabs. So you could use a dashboard to create a chart tab and then have the different tabs inside the charts. Like the chart tab could be an amazing feature that they can look at the different charts inside their chart tab. So I think that would be a lot better than a radial button on the bottom, because right now it's a little bit like, you've got this right here, but what if it was on the side menu and you could click which graph you wanted? So it's kind of the same thing as a radial button then, but you don't have to worry about a bunch of if statements. Then you would just say like, on this tab have this graphic, on this tab have this graphic, and then the person would click it. So instead of radial buttons working on little sub tabs, name the volume. Yeah, that would. So then what you want is, let me show you visually what you want, and I can put you in the right direction of this. So dashboards. Okay, let me show you what you want. This one already created right here. Yeah, I think someone's already got right here. Well, that's interesting. This is a very interesting code. It's headed in the right direction, but there needs to be some style improvements, I would say. And this right here. I would make some style improvements. So that's kind of a big thing right there. This is what I'm talking about right here. I'll show you. Let me go to the main screen. So this right here, they kind of did in an interesting way, but I went and grabbed this code really quickly. This is on Reddit. But so Adam, if you had a graph tab right here, and it's even got like drop down, you could go to these individual tabs right here. Does this make sense? Like stylistically, this is going to be a lot better if you have like a graph tab right here, and then you can click the graph tab and go inside of here and click the different tabs. There's nothing inside them right now. You can even choose the icons on them if you want. But yeah, so this code right here was found via Reddit. So thank you, Reddit. Pretty quick code right here. This is the kind of stuff we can take. Like this, I highly encourage taking stuff like this. It's not necessarily taking, it's kind of like a skeleton or a structure. Yeah, so we want to think about how, like, okay, so the radio buttons would work, but in truth, if we're going to create these sub menus right here, they did it in a very interesting way. The way they did it. So they got menu item right here, menu list. They're using their menu list. So you could just create your own menu list, but they're creating their menu list right here. They're doing icons, these things right here. So using their same structure right here with the dashboard layout, you can see the sidebar, menu item, menu, and then they've got the menu list. All of this right here, but you could go in and do your own stuff. So sidebar menu, menu item, and then main menu, and then they have the menu list inside of there. I'm just like double checking. And then we could go right here. So let's do this. Let's go to menu item. And we go here to a second menu item. And we say, so we could call this graphs. And then on the second menu item, we just call this like numeric output or something. It's not a good answer for it. And then that's their menu list. And the menu list is this menu sub item. They're already creating a menu sub item. So let's just call it menu sub item. There's menu sub item. And menu sub item takes text and icon, or we can just call this like hello. Should work. Cross your fingers. And numeric output, and it says hello. So does this make sense right here, Adam? Like you could have these different things right here. And if you think about the way this looks, I mean, this looks like an app you might see online or like, really cool professional stuff. So this just has, I think, the default icon, but you can have your drop-down menus right here to select between stuff and go to numeric output and click this tab right here. And then you'll store it in the tab and you could just make it. So rather than using radial buttons, you could have like, here's my graph. And this is a really important thing right here. And look at how much we've created stylistically, structurally. And how long have we been working on this, would you say, Adam? Maybe 5-10 minutes? But the thing is just knowing that these things exist, knowing that this is created, and then saying, okay, well, how are they creating the, menu sub item right here? So they're creating it kind of outside the app, which is fine. But you could create it inside the app. Like you could literally take, so they're using an lapply. Well, I've never used lapply that way. That's interesting. Oh no, they're creating a user input function on the lapply. Woo! That's neat. That's neat, but I've never done that. Yeah, no, and that's the thing is you can always improve these. You can always change these. We're not going to be too hard on the grading, but we want to, hopefully the goal is, when we think about the style of the app, it's like, oh man, like you pull this up and then you've got like here your stuff and you pull up your graphs, you pull up these things, maybe you have an instruction page at the start, and then you could go through here and like work with the app, and you could like even close down the side menu bar right there. So then you could just focus in on the graphs or whatever you're looking at. So, this would be really neat right here. And it's easy enough once we've created this kind of backbone for it to go in here and create another menu item. Whoops, just deleted it by accident. But we could go right here and create another menu item. Boop, sidebar menu. Here's the menu item. And we're just going to copy it. I don't think I copied the whole thing, though. And we just go here and go here to say other item. And then we'd go right here this and say more info or something. And so now running this right here, we'll see another menu item. And then we just need to start filling these pages with stuff. So we can actually start like going in here and doing our graphs, doing our stuff, and get this really cool layout. So this is kind of what I'm hoping we go towards, and kind of my gold standard. You don't have to use a dashboard layout, but I think it's like folders, it's like more organized. I'm sure there's ways to do it that I would give a top grades to that don't use this, but I would highly suggest for 475 going towards this sort of ideas. And we put the link in the chat to get kind of the basic bare bones structure. Once again, we're just kind of using what they have right here because none of this is very unique code right here. The dashboard header, the dashboard sidebar, the sidebar menu. The only interesting thing they did right here was they created a loop or of sorts to put these things inside of here with the names and stuff, which there's their icons, which, what we're going to do? We're going to put that in our Xbox because there's a lot of cool icons you can use right here. You can just grab the Xbox icon, which is what I love about it. It's like, oh, you just put the Xbox icon. Of course I know that one exists. But yeah, so check that out. I don't think Nintendo exists, though. PlayStation, I think, exists. We got to look. And then we'll do a little more 201. Okay. Sorry, I just love doing this kind of stuff. Does Nintendo exist? Nope. Broken icon. There's a list of icons. I think it's the Font Awesome icons. If you're looking for the list of icons, check out Font Awesome icons. That's where these are found. Just Google it, Font Awesome icons, and then you can see what is available. And with that, let's do a little more 201. Adam 13, 100 points. Great work right there, Adam. A lot of cool stuff we can do with those apps. Remember, it's all about your imagination. It's all about looking stuff up, finding what's out there, because there's so many things we can do. There's limitless things we can do. And, oh, that was the shiny question. When did we start that? We started a while ago. Oh, no, I need to check time on this. Started that a while ago. Okay, we got the car prices. How does the car price question start? Well, mortality and calcium we haven't done today. We haven't done the mortality and calcium question. So we might do that one. If you have the car price. Oh, you're welcome, Adam. Thank you so much. I know. Sorry, man. It's been a crazy week. Oh, here's the car price one. So we can do the car price. This is a different car price question. Car prices. I appreciate it, Adam. That's a lot of hard work. Tough questions. I should have Stat 201 car prices, chapter 7. Here we go with the car prices. Let's do it. Here we go. A little bit of a speed run on this one. Not too much, because we got 2 questions due. We're going to try and put a bolt in this video right here. We've got right here the equation of y hat equals b0. This is b0, but that's not the answer. That is the notation for the intercept, and this is the notation for the slope. B0 is when x is equal to 0. We expect y to equal b0, and b1 is when for each 1 unit increase in x. Going right here, we can take the information and we can copy it. So I click that little button. We can copy it right here to copy to clipboard and hit Control-C or Command-C. Control-C or Command-C. There we go right there. We've got it. Now that we've got that information, we're going to go right over here to jump and go to File, New, Data Table. File, New, Data Table. File, New, Data Table. With this, we're going to go to Edit, Paste with Column Names. Edit, Paste with Column Names. Now make sure it's blue. That means it's quantitative. We want to predict price, meaning it's the Y variable, hence it has the hat on it, from age of car. So let's go ahead right here and do Analyze, Fit Y by X. That's Analyze, Fit Y by X. We're looking for the intercept coefficient and the slope coefficient. With Analyze Fit Y by X, remember we're predicting price, meaning it's the Y variable of interest, from the X variable, meaning it's the explanatory variable over here. And we're going to go ahead and click OK after putting them in the Y and the X boxes as shown there. Have you gone over the visualization? We haven't done that today, Ruby, but we do have the visualization videos, and I can do that. I did a little bit yesterday on it, and we can do that tomorrow if you like. So we're going to do 2 more 201 questions. But let me know if you have questions, and the visualization playlist will show up, and there is a video going over it. And we talked about the residual plots in yesterday's office hours. So Ruby, thank you so much. 100 points, Ruby. Thank you for asking. We're going to go ahead and fit the line right here, which is kind of what we're doing for the visualization this week. This is kind of fit line right here, visualization. And now we get the regression equation. And here is the intercept. The intercept is the first value. You're welcome, Ruby. Thank you so much for asking. There's the intercept round to the nearest integer. We're going to round age to the nearest integer too? Sure, I guess we will. And so let's go ahead and take age right here. Sure, that rounds to the nearest integer too. Round these to the nearest integer. And there we go. Be careful though, because age has a negative coefficient. I almost made that mistake. Age has a negative coefficient. Do not forget that. That is super important. It's not a small mistake, and if I made it, I would lose the points too. Age has a negative coefficient because there's a negative slope. Very important. Prices do not increase on cars as they get older by age. The slope indicates that for every 1 year increase in age, the price of a car is expected to decrease, that's key right there, by this on average. And they're going to say round to the nearest integer. Good on that. Explain the meaning of the y-intercept. This would be a brand new car. You want a brand new car. So the intercept would be a car of 0 years of age, which means this is a new car. The intercept is a car that has 0 years of age, would be expected to cost this much. Good stuff right there. If you want to sell a 7-year-old car, what price seems appropriate? So a 7-year-old car, we need to go back to our equation and plug in the value of 7 right here. So we're going to plug in 7 for age, multiply by 746, and that needs to be subtracted from. And there's the selling value. If you notice it decreases with the age, we're going to destroy the bot right here. Hard use on channel. And so now we go down here and we put in the dollars right there. You have a chance to buy one of 2 cars. They are about the same age and appear to be of equal quality. Would you rather buy one with a positive or negative residual? So let's look at this visually. This point right here has a positive residual. This one has a negative residual. If these are the same cars, which of these points would you rather buy? Well, let's say they're the same exact car. The car with the negative residual actually costs less. So the actual cost of this car, let's pretend they're the same car though. This car costs more than the predicted amount. This car costs less than the predicted amount. So the negative residual. So the negative residual will be better because its actual price is below the predicted price. And that's what we see visually right there. You see a for sale sign on a 14-year-old car of this model asking for this. So this is how much they're asking for it. We need to find out the predicted. We're doing a little bit quickly right here because we're going to try to do one more really quickly after this. So you see a for sale sign and a 14-year-old car. So if the car is 14 years old, let's predict how much we would pay for it. We need to go back up here and put in 14 for the age of a car. Then we need to multiply it by 746. And there is the amount right there, 17,439 minus that. This is the predicted amount. So we just found from the equation the predicted price, but the actual price is that. So the actual minus the predicted. So we're going to get a negative residual right here because the actual is below the predicted. So let's copy this and go actual minus predicted, and that is the residual. So it's below what we would expect to pay. We expected to pay about $7,000. It actually costs this. It has a negative residual. Would this regression be useful for a 26-year-old car? No, because that is outside the bounds of the data. The data does not go that far. The data only goes to 12 years old. So let's find an answer that says that. No, because, and I also think it'd be negative. No, at least that's weird. They kind of make sense of it. I wish they just said it's way outside the model. You could look at this visually over here. 26 years is negative. You go right here to about 26 years, and it is negative. So a negative price of a car doesn't make sense. So the no, because the price of car is negative, which does not make sense. I think we've done everything right. Woo! Gotten a little scared right there. Let's do that last question real quick right here. We got it. We got the calcium and water question next. So here we go, getting the calcium and water question going with the last question of the day. 1 out of 6. 55. Mortality and calcium, stat to 1, chapter 7. Mortality and calcium. Let's do it. Okay, so the mortality and calcium question. We should find it. Here we go. We just did car prices. Oh, we might have already done it. Is it the last one? No, that's wildfires. That's wildfires. Here it is. We just found it. Okay, so the mortality and calcium question. Wow, that's a strong regression. This is a very good regression because it's linear. It's 2 quantitative variables. It's straight enough. That's linear. There's no real outliers, and the plot remains relatively thick. So this is a great regression when we look at it. Good stuff. Great job. So it's very strong, fairly strong. It is negative. It is linear. Towns with harder. Now, harder means more calcium. Towns with harder water tend to have lower rates of mortality. So that is true. Harder water, you have to know that. So you got to know a little bit about calcium and water. Harder water is associated with lower rates of mortality. Good stuff right there. Regression equation is the estimate of the intercept. And then we have the estimate of the slope. Do not forget the estimate of the slope is negative. I do want to point out this looks a lot like the jump output down here on the bottom where we get the estimates. So do remember that your jump output looks very similar here on the bottom where you get the estimate of the intercept, the estimate of the slope. And that's what you're seeing right here, the estimate of the intercept and the estimate of the slope. It doesn't say estimate, it says the coefficient, and that is the coefficient of the intercept, and that is the coefficient of the slope. For each 1 unit increase in calcium, the model predicts a decrease in mortality because it's negative. Explain the mean, the y-intercept. The model predicts that a town with 0 calcium would have a mortality rate of this because that's when x is equal to 0. The largest residual is 104. Explain what this residual means, and that's a positive residual. So that town is going to have a higher calcium. It might be that one or that one. That's going to be higher than what we predicted. Their mortality, the mortality is 104 more than we would have predicted. So the town had 104 more deaths than the model predicts per 100,000. I've made that mistake. These deaths are in units of per 100,000, so they have more deaths per 100,000 than predicted. The hardness of a certain town is 116. Use the equation to predict the mortality. Okay, so we're just going to go back up here, and we're going to put in 116. For x, we're just using it to make a prediction. And do not forget to subtract. And then there we go. There's the prediction. And did it tell me to round these? No, it just said carry them. Okay, I'm a little worried doing this one very quickly. Explain the R squared. This is the percent of variation Y explained by the variation X. 96% of the mortality can be accounted for by calcium. That sounds correct. 96% of the variability in mortality, can be associated by a linear model on calcium. Much better. Okay, that's better because they say 90. They don't say variability right here. 96% of the mortality can be explained by the 96% of the variability in mortality can be accounted for by the linear model on calcium. That sounds accurate. Boom, 100. There we go. I got a little bit worried. I was doing them a little bit quickly. And do remember, when you do interpretations, follow our guide for interpretations. We're going to be having class here in just a moment. So I will see people in about 7 minutes. I'm going to go grab some food. Until then, bye for now, everyone. Bye. Speedrunning questions here on Stat 201.